So again, today's class is really going to look at the relationship and the uh, of skylights and other fenestrations and energy conservation, right? And so that's kind of the focus is going to be on those fenestrations today. If you do have questions, make sure you put them in the chat, put them in the Q&A. I have good internet, so we should be good today. And I appreciate everybody joining. If you do have questions along the way, you can always check out the Minnesota Energy. Oh, the Minnesota not Minnesota, New Mexico Energy Code Support Program. You can find that information and link it there, and always check that out. We are Hope is working on getting that website all prepared with different technical resources, webinars, different information. But if you do have a question, you're looking for a flyer, you're looking for something, you're looking for a handout, or maybe a quick QR code link or link to a particular video, feel free to reach out to us. We've got those somewhere in the repository, and we can send it to you so that you have the information that you're looking for. I know Hope is going to bring some different resources to that upcoming training in Hobbs. And so with that, I mean, again, with that, she'll be able to provide some different updates on where we are with that website migration. So, you know, when we do these trainings, I think one of the things that's important to me, and again, I've said it every time we get together, 95 times I've said it on this to us as a team, that when we understand the why behind what we're trying to accomplish, we can better figure out how we actually do it. And I know it sounds like we repeat it over and over, but I think it is fundamentally important for us to understand that in the adoption of the energy code by the state, what we're looking at is a system of codes and regulations that are really designed to be flexible and innovative in providing an effective use and conservation of energy over the lifetime of a building, right? That's really the plan. And I get all the time contractors and plans examiners who ask that questions, who say, well, or designers that say, well, you know, it's really difficult to make it fit the energy code. Well, that's, you might be looking too narrowly at how it's supposed to be in there. And some of those provisions that maybe allow for different types of fenestrations or material selections or design variables, those are all there because ultimately what we're looking at is what's the intent of the code. The intent is to provide a method or a flexible method of identifying that energy use and monitoring, maintaining, or doing what we can to conserve energy use over in that building system, whether that's, again, residential or commercial. And when we think about and a lot of times when we think about it, fenestration is one of those pieces that comes in. It's one of those, we know the buildings are going to have it. If there is one section of the code that I regularly put into my plan review comments, it's on fenestration, because we know where they go. We address issues of, glazing safety. We understand when we have impact areas, we have different things like that. But the one thing that we don't really talk a whole lot about, or at least adequately understand, I think, is windows and fenestrations. I taught a class recently this week on residential mechanical ventilation systems. What does ASHRAE 62.2 say? Next, in a couple weeks, I'll be doing in the commercial side. And the one thing we talked about was that when we look at a building and where do we see the greatest level of air leakage, it's really around these fenestrations. That's why if any of you have done spring cleaning, or if you're preparing for the winter clean, right, that fall cleaning before we go into the winter season, we start checking. The first places that I clean is the window wells. And you would wonder, well, how do the window wells get so dirty? Why do they have, you ever notice that dirt isn't uniformly applied either? That dirt that accumulates is always at the corners. Why? Because that's where air is moving, right? We understand there's going to be some leakage. No window is perfect unless it's a straight piece of glass. But for operable windows, especially when we start looking at windows and doors, it's always around. That's why we put that little uh, floor mat, doormat, right by the door back at the garage. At least I do, right? I put one on both sides of the garage landing, so that again we try to mitigate and control any air movement through these systems. Because what was the point of putting together an entire building that had air leakage controls just to put in a series of windows and fenestrations, doors and windows that really negate that and allow for that uncontrolled air movement. Now, again, I am completely not aware that if we open a window, we are creating and controlling that level of air movement. Like I said, it's beautiful this week. And so I've actually opened the doors. And as a result, I've got a little bit of a little sniffle, right? Because I'm getting some of that farm field freshness, right? As the neighbor across the road is, maintaining his crops. So again, we understand that air quality and energy efficiency are all functions of a good thermal envelope, which incorporates good fenestration. And that's where I think I really want to kind of keep that in the mindset as we look through some of the conversation today. Let me go ahead and throw one more time in, excuse me, into the chat, the handout for those that want to follow along. And so again, when we think about this process, to me, it's always simple to keep it this way. What are those things that we're trying to accomplish? What are we trying to do, and why does it matter, right? And part of it is to define what that fenestration is, explain how it's going to operate, and that way we can review it properly and then verify it in the field, right? It seems like it's a really simple, holistic approach to what we try to accomplish when we do plan review. And when we review the buildings, whether we're doing commercial or residential, one of those key 4 pillars that we're looking for is going to be our thermal envelope. And like we've talked about before, within that thermal envelope, let me get my laser pointer ready. Within that thermal envelope, we're looking for 4 key considerations. At least that's what I do, right? When I do plan review, which I do a fair share of plan review focused directly on energy compliance, I always look for these 4 key characteristics of the building thermal envelope. Not to say I don't look for other things, but these are the 4 key things I look for every time. And that's the location, the materials, and then the fenestration, and then the air leakage that's associated with it, right? That fenestration is really, like I said, one of the things that in plan review, I am constantly reminding people of their responsibility to provide those fenestration factors and solar heat gain. They'll tell me it's an interior. They'll tell me the size. They'll tell me that it's going to be this jam or this material or what have you. But what they fail to always put is a column or a section on that. Very, very rarely do I see consistently a column that says, here's the solar heat gain, here is the projection factor for this window, here is the U factor for that window, right? A lot of times we'll get some information, and we'll talk about the information that we do get. But again, these are fundamental things we need to understand so that we can evaluate this for code compliance. Because ultimately, remember, that's what we're trying to do. Verify that this building is going to be compliant, that the uniform expectations that we have for buildings throughout all of New Mexico are followed. And that means we have to think about these systems or these assemblies within our wall system. And it also facilitates that inspection process, right? Again, if I know what I'm looking for, then I can better actually verify it. If I walk on site and all I see is that, I'm looking for a 3050, or I'm looking for a specific size window, and that, yes, I know this needs safety glazing. And that's all I'm looking for because that's all the details I have. And U factors are a 3rd item in the list of importance. And so they're not included. Then I'm going to have that problem of, okay, well, I saw the safety glazing etching, I saw the sticker, I'm good. I just move on, right? I'm not looking at that paper that says, oh wait, I've got a 0.3 window and the plan calls for a 0.27, right? I could sometimes even verify that before the windows come in. The contractor can verify that depending on how the inspection schedule is going, right? So we can make sure we order the right things if we're clearly aware that these things are in there. And that's, again, why I always make usually find a comment related to it, because I know that my inspector is going to want to see that when he gets out in the field. And that those openings, again, are part of what the New Mexico building code requires us to evaluate, right? Under 14539. It's one of, I think it falls under multiple places, right? We're looking for that opening flashing, right? Because again, we understand the impact of air movement. We don't need dirt, dust, debris moving into our occupied spaces, affecting potentially some of the different thermal resistance materials, or affecting the indoor air quality, right? We take time, maybe we don't do it as much as we probably should, but we take time to calculate that indoor air ventilation rate. We talked about, no, we didn't talk about whole house mechanical ventilation. We talked about pools that week. But when we talk about those kinds of concepts of mechanical ventilation and indoor air quality, we're using that window as part of that filtering system, right? Let the light in, not the air, right? I was driving home last night in the car and I thought about it in prep. I was thinking about today's class and I thought, for a while I had the window down and I went to, my kids wanted Burger King. I don't know if you guys go to Burger King, but their flame broiling causes particulate to get into the air. And so we pulled up and my wife, I rolled down the window, she was with me and she said, "Is that your car? It smells like it's smoking." No, that's the restaurant. You just never noticed it because the windows were controlling the interior environment. And then as I drove off, you could see the haze that was created by the particulate around the lighting fixtures. It was visible, the particulate from the flame broiling. And so again, that's one of those things where when we think about that in the context of a home, we want to have a controlled environment. We think about that in the context of an office. I should have said office first. We think about in the context of a home, again, whether that's a residential or commercial code, we're looking for those openings, making sure they're properly flashed so that, again, we can control the environment. We can control what's going on inside. Get the light, control the air movement, control that thermal heat gain or air or thermal loss, right? And we can also roll into our energy inspection expectations. That's a whole nother conversation. I try really hard not to, in my experiences, I have tried really hard not to make or identify an energy efficiency inspection, right? I try really hard to throw energy into all of my other inspections so that, again, it becomes second nature to the contractor, that when we look for when I'm doing a framing inspection, right, I'm looking for that air barrier. I'm looking for that moisture barrier, right? If we're going to throw in some insulation, yeah, we might have to do an insulation inspection. But really what we're looking at is the continuity of that insulation in relation to the other systems. And so I'm going to look at the framing while I'm doing that insulation. Digression on that part, but again, I think it's really important that we try to integrate those to create, or not to unnaturally, but to naturally create that recognition that it's all part of the same inspection practices. It's all part of the same construction practices. Like I said, I was teaching a class Tuesday. Well, and one of the building officials said to me, well, I don't think we get these air quality or ventilation rates in our current information, do we? Do we get manual J's? And I said, well, you should, right? It's required by both the mechanical code and the energy code. And I said and in the residential code. And I said one of the other things is, especially when we start talking about new technology and new materials, new equipment. I've been doing a kick on A2L refrigerants lately. A lot of people have been asking about them. And what it really, for me as a building official, comes down to is just understanding that contractors are going to be more aware. They have to, if they're following the manufacturer's installation instructions for these pieces of mechanical equipment, then they're going to have to be more aware about the ventilation, the impact of what's going on inside the building. And so they want to know that ventilation rate. They want to know, or they'll need to know that ventilation rate. They'll need to know that, again, air leakage rate, so that they can compensate and make sure that the system, the fans, can mitigate any potential refrigerant leakage. So again, it's something that they're supposed to be and learning to do. And so I think more and more we're going to see it as a common practice or a general awareness, even in some of the smaller towns, because you get a new system and they're going to have all these new requirements. You're going to have to, someone's got to read on it. And so it's going to be those, hopefully it's those contractors, right? But again, we all know that those windows and those fenestrations, those doors, are part of our building's existing wall envelope, separating the environment from the interior. But again, it's also part of that, obviously, part of our building thermal envelope. Now, again, this is why it's important to mark this out, because you may be in an environment where the thermal envelope is not consistent with the building's thermal envelope, the building's wall envelope, right? The one and the other may not always be the same. And so that's why it's really important to understand and have those visual depictions. We were looking at a grocery store the other day, and they made special effort to insulate a vestibule area so they wouldn't have to control the temperature inside it, right? So that they could say this is, or again, a bank, right? We all know some banks have that walk-in area where you can get access to the anytime machine, right? Or ATM. I call it the anytime machine. And so when not the automatic teller, that's a whole different thing. No, I'm just kidding. Digression. But when I go into that room, I know that I'm going to be inside a space that operates outside of potentially that general operating schedule of the bank. And so again, how are they ventilating it? How are we maintaining that? What type of fenestrations are we putting in to make sure we have consistent safety, as well as thermal separation? But I asked the question, when is a door not a door? Okay, this is the old dad joke right there, right? We all know, when is a door not a door? When it's ajar. Wah, wah, wah. Right? But no, really what we think of when it's a door, it's the code provides us a variety of ways to define that door, right? We have a building entrance, which is that portal that's used to gain access to the building from the outside, right? So that we have some expectations about entrances versus building entrances versus entrance doors, right? An entrance door is a door that's used. Well, we see here it's a vertical fenestration. It's not that's over 50% glazing, but that's more of that occupant egress, and access, right? So we may have a building entrance at the front, but all of us in our offices, we know, right? All of us know there's that back door that we can always go out when that one citizen, that one contractor comes in that just drives us crazy. We all know that door, right? My door was right by my office. And so when I would hear a particular voice, I somehow magically had to walk out to the truck. And my secretary knew, our permit tech knew. She's like, oh, I'll find him. He's not at his desk, but I'll find him. Hold on 1 second, right? So we have so there's a difference between the building entrance and an entrance or service entry door, right? We sometimes call them service entry doors. There's also an opaque door, which is a door that has less than 50% of the surface is glazing, right? So we may have a solid door versus a glass entry door. So again, we have these differences in order to evaluate the glazing in it, as well as how we rate the U factor, that thermal envelope. My back entry door was a completely solid opaque metal door, right? With a little bit of foam inside. It was well sealed to where when it would get cold, you wouldn't hear it. But the moment you touch that door and start to unlatch it, it would fly open, right? Because it became a sail in our building environment. And so again, we want to make sure we understand there's some differences between the types of things that we see. I need to kick it into high gear or else we'll be here all day. And that definition of what is a fenestration is again really based on vertical versus, I call it horizontal, but we call them skylights, right? So when it's not less than 60 degrees from horizontal, it's considered a vertical fenestration. Once we exceed that 60 degrees, right, we lay it down enough to where we hit that 60, then we become a skylight, right? And so I think that's important for us to understand in the context of how we evaluate that U factor thermal gain, solar heat gain. So we'll get more solar heat gain from a skylight, but we'll get more potential conceptually, according to the building science, right? Because this is a different plane. And so as we get lower, we're getting less impact from wind, but we're getting more direct impact from the sun. And so we'll see those values kind of start to teeter a little bit. As we get more vertical, we care more about U factors. As you get more horizontal or more skylight, we're thinking more about solar heat gain. We understand that buildings in general, and the code has required this for many, many decades, require a level of natural ventilation, right? When we're not providing another alternative option, we provide natural light. And so again, we'll see a lot of windows in buildings, right? That's supposed to be 8% of the floor area. On average, I'm seeing most wall area, surface wall area, we're somewhere between in residential 12 to 14%, right? If you're up north where you get a lot of cold or a lot of wind, you may drop that number down, but I've not seen it go below 11% in most of the plans that I've seen, most of the projects I've reviewed, right? But when we look at that number, and the reason I bring it up is that number is provided if we're doing a comm check. But or comm check or res check, we'll see that percentage of fenestration area. That's a wall surface area. The code requires us to calculate it based on floor area, right? The 8% of the floor area of each room. And then we have to provide openable area for ventilation and at least 4% of that, or half of that potential window. We can talk about that in another conversation about the requirements for ventilation, if that's something you guys want to talk about. Always put your suggestions. We have pretty much set the agenda for the rest of the year. However, I'm always looking for I'd rather talk about this kind of question, right? So if you do have a topic, let us know so we can either put it, maybe move some things around and can an idea that we thought was a good idea, because your ideas are what you want to hear about. So always let me know about that. Shameless plug for the survey at the end. But that same expectation we find in residential, we see in the commercial code, right? The commercial code, again, addresses natural light. So it's not just this thing where only residential properties have to have light. Commercial buildings have to have light as well. Now, what I will want you to notice is that this is, when we're talking about this space, this is not conditioned floor area. So you, again, and where we'll see a lot of the skylights identified in the code is when we're talking about those non-conditioned spaces where we're trying to bring in potentially solar heat gain, because we're trying to illuminate and then semi-temper those unconditioned spaces. Now, with code doesn't specifically say unconditioned versus conditioned, but I think that's one of those underlying themes that you'll see when you look at when and why it's addressed the way it is. When we look at the energy code, we know that as a building, there are certain things that we're looking for in that building thermal envelope in the commercial provisions and in the residential provisions. But ultimately, we identify, are they opaque elements of the building thermal envelope, or are they fenestrations, right? So again, in residential, it's all in one section. It's all just within that idea of insulation fenestration criteria. And in the commercial, we break it into two different ideas, two different concepts, different sections or subsections within section 402. I wasn't going to read all that. I just wanted you to know they're broken out. One of the things that we think about too when we look at res check or comm check, both of those are those mechanisms, those mathematical calculations where we start to trade off different elements within that building thermal envelope. And they incorporate, they do not separate or distinguish between fenestration and insulation. So they will look at the entire system that makes up a building thermal envelope, right? And so again, not just insulation, it's going to be both systems as we do that comparison, where we may drop down and be more efficient in a window in order to become a little less efficient in a wall system, or vice versa. Try that one, vice versa. I know that's not the right way to say it, but that's how I said it. Now remember, when we think about this, what we're doing is we're looking for that table, right? We're looking for that. Normally opaque doors we'll find down here. So remember, if it's an opaque door versus a building entrance, we might have differences. And again, depending on if it's an opaque door versus a building, where was our definition? Right? An opaque door different from an entrance door that has that fenestration. So again, we're going to treat that service door, that all metal door that nobody really thinks about, separate or different than what we expect in that fenestration. Now, again, we're looking at table 40214 in the commercial code. And so again, there's our values, that non-swinging, swinging garage doors, right, that have less than 14% glazing. We're looking down here. Similarly, when we move over to residential, like I said, in section 402.12 or 1102.12, we don't use the 11, we use the 4 because of, it's in the IECC. What we're looking for is those assemblies, again, are going to be part of that assemblies and insulation table, right? And so again, we're going to see here that we're looking at that 0.3.4 for that fenestration versus, again, 0.3.1. So depending on our values, we might get a little bit more flexibility in an opaque door than we do in a fenestration. Because again, what we're thinking about is not only air leakage control and that U factor value. If we look at it over time, and I put up here climate zones 3 and 4, because I know that covers a lot of the area. When we look at how this has actually changed, I like to once in a while remind us of how this has actually changed over the past, 15 years? Is that what I'm seeing here? Yeah, 15 years. From 2009 to the current code and in the future, which we can see the little bit of difference. I only want to show you this just so you know. And I will, these are the models. This is obviously, I forgot to, I want to make sure I clarify that here, because I just grabbed model numbers. We see that these numbers have not changed, or they took a drop back in 09 to 12 transition, but then from 15 through now, they've really not changed much. And as we look into the future, they don't change again. Our skylights, they don't change. They haven't changed until the future. And then our glaze, our solar heat gain in climate zone 3 is consistently been that 0.25, right? And we know that the ceiling R value, I just kept that in there just to show us that. Again, remember, we went with a 38 value. We moved forward and took that 38. So that again, we maintain. But look at that R value in that ceiling. If by keeping it 38, it's not changed in 15 years. So when people say that insulation is becoming the problem, it's not really the problem. It's flexible, right? Same thing over here in climate zone 4. We see that it's gone from 0.35, 0.32, 0.30, 555.4 versus 0.25. That's really the big difference, is in what our expectations are on solar heat gain in those warmer climates. So if I'm all the way down in Artesia, if I'm all the way down in Hobbs is 3. If I'm down further south in Roswell or Artesia, I'm going to get more expected to get more solar heat gain because of your proximity to the equator and closer to the sun conceptually. And so the window needs to be a little bit better at resisting that impact on our building mechanical systems. Versus if I was up in Clovis has got that, just that 15% better or 15% less impact from solar heat gain. If we were to look at the ASHRAE standards, again, we can see that they're the same, very similar design. So again, some people choose. I just grabbed climate zone 4 here. Some people will choose, remember, to use ASHRAE versus IECC. And so here we see that 0.5 versus 0.4. We had point for Skylights. Skylights 0.5 and 0.4 solar heat gain, 0.5, 0.4, or 0.55, 0.4. So again, they're getting a little bit more strict on that air leakage, right? Because remember, as that U factor goes down, we're getting less air loss, less thermal loss. And again, as we talked about our opaque doors from there. Now, one of the things that we think about in commercial specifically, like we said, in residential, it's all part of that insulation and fenestration. In commercial, again, we're going to the U factor table in table 402.4 in order to get those values for those vertical fenestrations, right? So that entrance door versus that opaque door, right? Opaque door is going to be in 402.13. The entrance door that has glazing, 50% of glazing, will be found in 402.4. And so that's, again, where those things that sometimes can confuse a contractor or a plans examiner is not really taking that break to say, oh, wait, what's the, am I looking at a fenestration or am I looking at a opaque door? Now, I want to remind us, as we talked about before, the code does say that if we don't provide this, we have to make some assumptions. And those assumptions, like I've talked about before, whether we look in residential or commercial, are not positive, right? In the way of demonstrating compliance. Because like most things we've talked about before with my kids, if I have to make some assumptions, the answer is no, right? And so if I'm going to assume some things about that opaque door that may not be accurate based on what we're seeing in the building, right? So if I'm seeing an insulated metal door, I've got an opaque U factor of 0.6, whereas the code is telling me I need a opaque door that's 0.3 in climate zone 4, right? So again, assumptions are not positive when we start looking at those compliance values. But really, what are we kind of getting back to what we talked about, kind of, what is it that I'm reviewing for? I'm looking for that thermal resistance, right? What is the U factor? What is the solar heat gain? I have the hiccup, it's killing me. What is that proper design? Are they used effectively? Do we see proper vapor and air leakage controls? Do we see proper flashing identified? Where do we see it in context with the rest of the building's thermal envelope, right? Are we getting, are we creating that continuity across the system? Remember, we're looking for a continuous air barrier, a continuous thermal envelope. What we don't want to see, and again, we see this once in a while, especially when we start talking about, I've had some conversations with people about, when we choose alternative building designs, right? I had somebody looking at doing a straw bale home, and they're going to do an 18-inch wide envelope. And so I asked the question, where are you putting the window? Is it on the furthest edge or is it on the interior edge? And what are you doing with that 14 inches, that 16 inches of dead space, right? Because are you gonna flash it so that we have good drainage, or are we just gonna have a seating area, right? We need to have that identified so that we think about those in that design process. That affects what we do when we do inspections, because again, we're looking for those same things. If I know they're on the plans, I'm verifying them in the field. And so I'm looking for, again, what is that thermal resistance? You told me a 0.3, I'm looking for a 0.3. I'm looking for that proper installation. So if I have those good flashing details, then I'm going to make sure that they're properly flashed and installed. And again, I'm looking for that potential air leakage. We've shown image after image of, when we talk about air loss, that fenestration is going to be one of those critical places where it happens first. I've shown you, we did some of those digitals when we talked about images, when we talked about air barriers. And I showed that hotel I was at in Albuquerque. where I was holding up the camera and I looked down and you could see light through the door, right? Because the metal, the rubber gasketing that had been installed was now gone. And so now you had a 20-degree difference in temperature in that assembly. And so that's going to affect. And so those are the things we're thinking about. I recognize that for the most part, when we talk about skylights, if they're leaking moisture, right, or rain, we'll notice that, right? But when they're leaking vapor, do we not recognize it as much, right? And so we'll start to see, and again, like I said, when you start doing spring cleaning or winter cleaning, you can see where your air leakage is taking place a lot of times in the window system, because you're going to see a little bit in that corner on that left side. You're like, okay, so something's wrong here. What do we need to do? Do we need to caulk it, or we need to seal it? Do we need to do something to, again, control that environment and maintain that equipment? Now, I understand we're not maintenance people normally, but a lot of us get involved in things where we have to worry about maintenance. And that's one of those conversations we need to have when you're checking, and maybe that's a good opportunity. I use that as an opportunity as a building official to go into my community and say, hey, we're maintaining, do some spring cleaning. When you do spring clean, identify these types of issues, and then this is what those are from. It's not just dust naturally settling. The reason the dust moves that direction is because there's air leakage that's drawing it from that pressure difference, right? It's unnatural. If we set up, I know I'm bald and I'm not Mr. Clean, but if Mr. Clean did set up a model design and just sprinkled dirt, guess what it would do? It would fall straight, right? It wouldn't move around unless there's air movement, right? We've watched enough of those vacuum examples, right? Where it just sucks it down and then it's gone, right? It's on the ground. And so again, when we think about that in reality, the reason we have dust and dirt moving to these windows, especially with, we have blinds, right? And in my daughter's room especially, I can tell when she's had her windows open or not properly closed, because there's a little bit of dust at the bottom of her blinds. Why? Because air is coming in, trying to get into our pressure, right? Trying to move from the outside in or the inside out. And so again, that's part of what we're looking for. Digression. Sorry. I'm never going to finish all these slides. So again, what we're looking for in that design is, again, where's those windows going to be identified? This is our wall, our exterior wall. We've got a site-built door that's going in. We're making sure we have continuity, making sure we have proper gasketing, making sure that we have that jam, that again, how are we verifying that we have good continuous air barrier control and thermal control? Here we see that aluminum storefront system, right? It tells us to go to section A6.03. We go to A6.03. We start to see the material identified, right? You can't read it, but that says that there's a storefront. But what it doesn't do is it doesn't tell me very much about the testing or the level of thermal resistance associated with it. I'll show you another example that I have where this is, again, another problem where it's like, you sent me somewhere and I got there, and once I got there, it wasn't working. It reminds me of the first time I went to a restaurant my boss told me about. I drove all the way down there, 2 hours to go to this restaurant, to find out he hadn't been there in 5 years and they had closed, right? Same concept. You keep pushing me to this, go here. I get there, and then I'm disappointed, right? It doesn't just happen it happens in a lot of different variables, right? So again, here's that place you sent me, that A6. I go to, well, you sent me to 6.03, which was this page. Even when I check out 6.01, I'm looking at the door panels. Nowhere in here do I see, even if I zoom in to these keyed notes, I see we have glazing, but I'm not seeing a simple declaration of a U factor, right? I see that we have systems. I see that we're going to have tempered glass. I see that it's going to have coatings to restrict visibility into the office. I see these things, but what I'm not getting, again, in that metal frame, I'm not getting a good idea of what is this thermal envelope. What is that U factor? What's that solar heat gain? Sometimes they'll provide us a COM check, right, or a res check, and that will provide in those sections in that proposed window system, right? So here I can see this is the only place where I found ever in this entire project a reference to a solar heat gain or proposed U factor, right? Here's that storefront metal break, the Kinnear trifab that we see identified here. We see it talked about here. That's the interior one. So again, that's what we're looking for. And so now I can at least confirm that that's the value that I'm going to see in the field. Now, because remember, U factor, we're looking at how much heat passes through the material. Solar heat gain, we're looking at how much it resists or allows through that wall system, right? And so again, when we're looking at those values, we're looking for solar heat gain. Now, when we review it, remember, again, we're looking solar heat gain, or we're looking at that U factor. Remember, what type of opening is it will tell us what type of U factor is the minimum expectation, right? So we shouldn't have a window that's worse, that is worse at restricting air movement or heat transfer than what we've got identified. And then similarly, when we go out in the field, we should be verifying these types of things and know that they're built different ways. So again, that flexibility is there. The code doesn't say, you can only use one type of window, or that you can only use one manufacturer or one style. It gives us that flexibility and says we need to throw it into one of these three boxes to evaluate that U factor value. And again, all of these different designs will provide that information. One thing that we're also looking for is that projection factor. Now, again, a lot of buildings may have a 0 projection factor. Code doesn't say you have to have a minimum. What it does is understands that if we have a projection over that fenestration, we are shading it, and therefore we are reducing potentially that solar heat gain through something other than the fenestration itself. And so what we'll do is, depending on if we've identified an overhang, then you're going to tell me, I'm going to say your fixed window has to do this, your operable window, this is your solar heat gain, right? Depending on your level of overhang, your level of projection. Again, I see a lot of projects that come in that have absolutely no concern. And so they'll go with the highest expectation and they put no projection. Okay, that's fine. Just know that that was an option that you had, was to cover it with some type of projection or covering so that you can reduce the overall thermal heat gain requirements of the fenestration itself. A lot of times we see this, especially around large windows in office environments where we may have a covered walkway around it. Perfect way to show that's a projection, right? We've got a little projection there. We've seen these, I think it was in Hobbs. Can't remember if it was in Hobbs or it was somewhere else that we saw those canopies over windows specifically to create shade for the classrooms. And so again, we can calculate that solar heat gain. Or not solar heat, yeah, the whole solar heat gain through the projection factor. And so we got a 5-foot height, or H, so versus horizontal versus vertical. And so this window would then have a projection factor of 0.38. It would fall within this line. And so as fixed windows in climate zone 3, they're required to have a 0.3, right? Consistent with what we saw in residential. And again, when we start thinking about inspecting it, what we're looking for are some very basic things. We're looking for, again, seals, right? We want to make sure that these fenestrations, these entrance doors, these entrance doors are properly sealed, that we're not getting moisture accumulation, right? When we go out, we see the installation of new fenestration, new vertical fenestration. We're looking for, again, how do we transition? How do we seal? How do we caulk? How do we flash? Again, I know that there's going to be a covering over this material, but how is it currently going to be connected? Because unlike just straight moisture, air is a little bit smaller particle and can have impacts. And we know in high wind events or high wind areas, it's going to have an impact on overall heating cooling. And that's why we need good flashing details, so that what we see in the plan is going to be what we see in the field, and not just a question of how do we design it in the building. Now, remember, there are methods for testing if we have site built or uniquely built window systems, right? Nothing that says we can't make our own window or hire a local artist to do something crazy and unique. Crazy in a good way, not crazy. And so again, we can use those in our NFRC testing materials and testing standards to say this is what that window is going to be. The code also gives some exceptions to certain size windows, again, so that we can allow for that level of flexibility. It's not this is every window has to look the same. We provide that flexibility. But it also has to, again, part of that, what we're looking at is that air leakage. So it may be less about the air leakage of the window as much as it is the connection of that window to the overall system. And we do a lot of that through air testing, either through qualitative testing or through visual assessment, right? We're looking for different things in that process. And so field fabricated fenestration, again, we're looking at different standards to say, this is how we installed this. How is it supposed to be evaluated? What is that standard we're looking for, and how we're going to test it? Sometimes we'll go out there, and again, this might be a pressure test. And some of these we can maybe show up to, and some of them we're just going to take a certification. 9 times out of 10, in my experience, I have very rarely ever been on site during a testing process or a commissioning process. It just never works out for my schedule as a building official. And so I got all kinds of certifications that came in, and I put them in the file to show if anybody ever asked, what happened to that? Did somebody test that window? Absolutely. Here's a certification. And if somebody lied to me on that certification, that's a whole nother conversation. You lied to the government. How dare you? Don't get me started on what happens to people that lie to the government, or should happen to the people that lie to the government. We won't get there. But again, what we're thinking about is, again, how does the system overall work? Not just the fenestration, but the fenestration's connection to our existing building thermal envelope. And most of us could look at this and say, really, Harmon, that's the picture you're showing? I'm telling you, it's because it shows problems, right? We got some problems going on in this, and we want to make sure that we stop it by talking about proper flashing, proper sealing of systems, right? And again, if we got good details, then we can prevent crazy installations, right? We could talk about what type of insulation is above that header, right? We're not going to go there. But again, we know that air leakage is a process, both residential and commercial, and there's different ways we can evaluate it. But there's more than just that one thing we're doing when we're looking at windows. And again, that's why I say, you don't have to necessarily always go and do a window inspection specific to energy. We're already out there. We're looking at egress openings. We're looking at emergency escape openings. We're looking at, again, how these things are being properly installed. And so it's very easy. To me, it was one of those moments to say, okay, if I'm looking at a window, I'm looking not just at one. I don't have blinders on to look at only the quality. I go out there, and I remember I did a window in a second story addition. And so the question was, well, we're just here to talk about the opening size. We want that emergency escape opening size. We want that 5.7 square feet of clear opening. And they were, when I got there, I was like, but that's not the only problem. That might be the only thing you're looking for, but that's not the only problem. We got some flashing problems. We got some, you don't have the right cripple, layout for it. This isn't going to support. They had no cripple joist under it. So and so it was like, well, what? Well, we just want to make sure this window works. No, it doesn't. Right? I can make 15 things wrong with that. I'm just kidding. It was 5 things that were wrong with that Windows design. So again, when we're out there, we're doing more than one thing. I think that's important for us to remember. I will throw this out there, a reminder that when we talk about the exterior vertical fenestration, the code does say there's a maximum of 30% of overall gross wall area. However, it says that if we get to that 30, we can choose to go to they'll give us a little extra in climate zones 1 through 6 to get us to 40, as long as we have some all of these expectations as far as the visibility transmittance of the glass, the daylight controls, the size of the building, um, and then again that we're quantifying that daylight zone. Now we've not talked about daylight zones and top lit zones in the context of this, and so remember those are important to calculate. Um, there is some minimum expectations about skylights based on the type of occupancy and the size of the space it's in. We're supposed to have at least 2,500 square feet, but no more than 3%. No, no more. Yeah, no more than 3% of the total. I'm saying this wrong. No less than 3%. So we got to be at least 2,500 square feet or 3% under that roof. In these different areas. And again, these are the office atriums, lobbies, concourses, corridors, storage, exercise, convention centers, automotive service areas, manufacturing areas, non-refrigerated warehouses, retail spaces, distribution centers, transportation depots, workshops. Again, part of the reason why we're doing this is because we're trying to get, again, additional light without, in my opinion, we're trying to get additional lighting into these spaces that we know are going to have a lot of energy consumption in the first place. And so again, these specific types of uses are to have these minimum fenestration skylights expectations. And again, that skylight comes with a top lit zone that we have to calculate. And so a lot of times, again, we see these utilized. However, no matter what we say, as far as it's always interested me that we create this, hey, we're going to have a maximum, we have a minimum amount, we have a maximum amount. And then we get crazy and we always have some weird design. Right. And so we have times when we create atriums that have these huge spaces of windows, and we're not really thinking about how that's going to affect the overall heat consumption, right? That solar heat gain. This was right outside Dallas. This is the Gaylord Resort. I was there a couple months ago, and it was a beautiful day, and it was nice and cool in the shade inside. But when you walked out into the lobby, into this little atrium area, and that sun was coming through that glass, it heated up pretty quick. And I'm going like this a lot, trying not to sweat to death and embarrass myself in front of some other people, right? Because again, we're not thinking about the ventilation requirements and the impacts in some of these designs. And so again, that's something that, again, the code is starting to move us towards, hey, think this through as we get to this. And when we exceed those 40% values for vertical, then we have to go to an alternative compliance. And again, if we're going that direction, I'm really going to focus on, personally, because I've been in that kind of environment, I'm focusing on ventilation and mechanical design. So those windows are, because I know those windows are going to be creating heat inside those spaces, even in the middle of winter. And so how are we ventilating? How are we maintaining the temperature so that it's not 85 degrees inside the building? Digression. But again, there are certain exceptions to the skylight requirements, and the code provides as far as, different climate zones. Those climate zones might happen in some of the higher elevations in New Mexico, but for the most part, we're really looking at, what is the daytime operation, right? Because we're expecting this is going to be something that happens during the day, during the work day, right? That 8 to 4 p.m. How many hours are people going to be in this space? If we don't use it, then it's really of no value to have that skylight when the darkness, because a skylight can turn to a dark light real easy and start to consume or create that glowworm effect. I call it the glowworm, right? And especially in today's communities, a lot of them are creating dark sky requirements, especially in where we don't create these huge areas of external illumination, right? And so I have a project that has a huge skylight as part of an atrium, and at night when they turn on all the lights inside, it turns that into what looks like a literal spotlight shooting into the sky. And I've gone over thinking, oh, we're doing an event? Oh no, it's just the atrium. Atrium's lit. Great, right? So again, we don't want to create the glowworm. So if a building is not going to benefit from those skylights, then there's a way to become exempt to them. Again, we can use ComCheck or different mathematical calculations whenever we have those large numbers. Real quick, I got 5 minutes to run through this. Here's an example of one that identifies those skylights as part of a alternative compliance because they're going to have a lot of lights. Go to the lighting section. It says, hey, we're going to have lights. They're going to be insulated. See the specs. So I go to the specs, and guess what the specs say? It's going to be calculated, right? It tells me it's not going to be more than 0.4 BTUs per thing per. So again, I've got a U factor calculation, right? But then I also see where they've got this entrance door is going to be not more than this, 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 and this, right? And insert a value. I need to have a little bit more detail, specificity. Is there certain areas, right? Or is the solar heat gain going to be 21, 0.21, 0.25, 0.35, 0.40, 0.45, or what? I'm not sure. So maybe we need a little bit more definition on that detail. So thanks for sending me to the spec book. Is that spec book helpful? Or we forget to do something? And I get it. These spec books can be 1,000 pages or more. But we see here a wintertime U factor versus a daytime U factor, some dynamic glazing that's being used, right? Or we're expecting that this is going to again maybe allow for some cooling that's going to reduce the size of some of the gaskets. I'm not sure what's going on, but there's a lot of things that could be happening in this particular design. Here's a quick look at a house. Again, we've got all the R values, what's being provided, and then we have this nice note down here. This is my U factor, my minimum U factor, right? Great to have. That way, when I go out there, I know what I'm expecting as far as a uniform window system. All windows to meet the energy code. But again, we see that number there in that energy compliance table they provided. Here's another example of a hotel. There's a energy compliance methodology. And so we have those opaque doors. Part of that mathematical calculation, that process that's run is based on what types of windows, right? What types of vertical fenestration versus opaque doors versus, again, other factors, other window factors. And then how do those, and again, this is the application. We see where those windows are going to be. And so they've labeled them. These windows are going to be here. These windows are going to be there. We can kind of see some of those air leakage requirements. We can see those thermal resistance values, that air leakage rate associated with the window itself. We're taking that even lower. And so what we'll want to, the question is going to be, they're going to be tested. So how are we verifying that air leakage rate? Because they're taking advantage of that lower air leakage in order to justify part of their cost calculations. Right here we have our double pane thermal windows. This says 0.9 and 0.9 U factor, 0.029 U factor, and a solar heat gain of 0.39. Well, that's not consistent with what we got here as far as those openable windows. And so I'm going to ask them to verify, because 0.029 is a significant number versus 0.38. And so is that part of is your math off, and that's why you're getting 20% reduction in energy use? Maybe. I'm not sure. That's why you ask the question, so that you can understand those little things. Again, here's how we calculate the daylights, expectations for lighting within those systems. And again, this is where Windows fenestrations and again skylights come in, and they have impacts in more than just the thermal envelope. They affect the lighting systems themselves. We talked about that. What we're looking for in plants, again, those areas. I'm going to skip through those. Again, like I said, skylights are something that we're thinking about in certain areas and types of occupancies, because again, we're going to use skylights, those red dashed lines, in order to provide natural lighting to this space. But again, not skylights and windows are not the only types of fenestrations we deal with. We deal with door seals, vestibules. Remember, we're thinking about those in the context of the different, when they need to be applied and how they operate and what those different exceptions. The thing that I have had a lot of things lately, especially in residential, the commercial code addresses operable openings interlock right? So that when that window is open or that sliding wall system is open, that it affects the heating and cooling controls. I've been seeing that a lot in residential. And so a lot of residential projects are starting, especially in beautiful places, as I know there are many parts of New Mexico that are beautiful. And so people may be wanting that slide away door or wall system, wall panel in some new construction to say, hey, I want to take advantage of this beautiful place in the low humidity. And so when we have that, make sure that we're thinking about those controls, that we deactivate the one system I saw late last week, deactivated the heating, but activated the ventilation to, again, create a positive pressure to kind of try to restrict air movement or particulate getting in, right? Created a positive pressure to keep pushing out air so that dust wouldn't fly in. Again, think about it and how that would operate as a design. If you have questions, please feel free to let me know. I know we're 1 minute over, but if you don't, we're going to get into some other questions looking at air barriers, installation, commissioning, and replacement mechanical equipment at the end of the month. And then we'll get into some stuff in October. If you don't already have it on your calendar, remember in 2 weeks, there's going to be that in-person training on Wednesday in Hobbs. So make sure you sign up. Let Hope know you're coming. Remember, the morning is going to look at the envelope. The afternoon is going to look at the mechanical systems and power and lighting requirements. If you have questions or other topics that, again, would be useful, please make sure you fill out that information in the survey. And you can always check out our website, find different resources, or email us at nmhelpline@shumsco.com. I do appreciate and love seeing everybody. Remember, this is class 95. So we got 5 more in our special that I get to teach before we get to that special 100th class with Josh. It's going to be special. You guys enjoy your weekend. You too enjoy Labor Day. Take some time to relax and enjoy before the week starts over again. But we will see you next week. Be careful, and you guys have a great week.